Power outage happens from time to time. Electrical faults will be habitual, particularly in rural areas where the distribution line were neighbored by different types of obstructions. For example, the overgrown trees, the fallen animals or branches will considerably perturb the distribution system. The situation becomes even worse when power outage happens in rural areas. It will take a lot of time for the electricity to recover after the power outage has occurred. But why does it take so much time for the electric supply companies to fix the fault? In fact, tracking the locations of the distribution line where the electrical fault happens could be just as challenging as finding the needles in the haystack. So now let's take a look at the current solution and its limitations. In the current solution, the inspect technicians will need to find out the locations of the fault by examining the electricity from one place to another place. Then they will need to inform the locations of the faults to the repair technicians. Apparently, one of the major disadvantages is that it takes a lot of time and effort to fix the electrical fault. Furthermore, it also requires different groups of technicians for finding and fixing the electrical faults.
In many situations, electrical fault at one area also means that it will devastate the power system at the neighboring areas. Thus, locating the fault will be very hard and takes a very long time to resolve the problems. So this is our solutions. At the first stage, there will be 3 line nodes aka detector deployed on the transmission line. Then the current data will be transmitted to the nearest tower nodes. The tower nodes is placed on the top of the tower and it can be communicated with other tower nodes with the presence of the line of sight, which means that there is no obstacle blocking the LoRa signal between each tower nodes. After that, the tower nodes will send the data to the gateway. The gateway is the final station for receiving the data and uploading the data to the cloud. Finally, the data stored in the cloud can be monitored by using the mobile phone and desktop. Automation SMS and email notification can be sent to the mobile phone once faulty currents detected.
This demo shows the transmission of the data from the line node to the tower node. We use LED to replace the current transformer. When the LED lights up, it means the data is transmitted to the tower node. Now we have 3 tower nodes and a gateway. The gateway's button is used to prompt the tower nodes to update their data to the gateway. It will also be done automatically after every hour. The tower nodes buttons are used to simulate different types of fault data. Then the gateway will upload the received data to the Microsoft Azure Cloud Service. Now you can see the recorded data in the SQL database.
We use the Microsoft Azure Machine Learning to build a model that could predict the types of electrical faults. Then the trained model will be deployed as an API for real-time inferencing. The Power BI desktop, you can see our dashboard over here. The user can select the towers to display their information. At the middle is the electrical stats of the power distribution system near the tower. The electrical stats was predicted by using the machine learning model that we have demonstrated earlier.
So this is the layout of mobile apps designed by using the Power Apps. You can just simply monitor the data from database by just using mobile phone. Automatic alert system by sending SMS and email notification also completed. Email and SMS will be sent to the user once a faulty current is detected. Why is better? By using LoRa, the data from the sensor and GPS module is transmitted in long range without using a cellular network. Secondly, the location of the faulty can be determined easily when a fault is occurs. Third, easy deployment on the transmission line. Lastly, there will only repair technician required for fixing the faulty of the transmission line. Our target segment is electric supply company such as Sara Energy, Tenaga Nasional, and Sabah Electric City.
Conclusion: we have built a long-range monitoring of transmission line electrical system by using LoRa technology, which doesn't require cellular network support. This product is a self-powered edge device which does not interfere with power distribution system. Furthermore, the real-time and consistent 3-phase power distribution system information can be received and evaluated in Power BI and Power Apps to determine the type and location of the electrical faults. Last but not least, we have also designed a fully automated alert system that will send an SMS and email notification to users when power outage and electrical fault occurs. We hope that our solution can solve our energy problems in detecting power outage and also improve livelihood in Sarawak when power outage can be handled easily. Thank you.